Hello everyone, my name is Shao Heng and I'm from SMKC Field, Malaysia. In this modern day and age, a lot of teachers are starting to use computers and projectors to teach in classrooms because they just like to use it to show PowerPoint presentations and play multimedia materials such as videos from the internet. It's just such an awesome teaching tool that teachers are using it all around the world. However, this is where we hit our first obstacle. Teachers, they want to be able to use their hands to make handwritten notes on their whiteboards. Teachers want to use marker pens to physically write and draw on their notes. What teachers don't like though is being forced to use something like this, which is a computer mouse, to draw and make notes, because when they're teaching with computers, they don't want to use this. And it's so hard to write with a mouse. And if you've tried writing with mouse before, I bet you it's gonna look a bit something like this. And that is exactly why we have whiteboards in the classrooms, so you can physically hold a whiteboard marker pen to draw and write things on the whiteboard. So that's our first obstacle. Projection screens don't have a touch screen, and you cannot write and draw on those computer screens. So this is like a projection screen right here, and I can't like write on this projection screen, and it's not a touch screen. So that's a bit hard for teachers to use as a teaching tool. Okay, so here's problem statement number 2. Yes, teachers like to write and draw on whiteboards, but a lot of teachers feel very limited by whiteboards. I mean, it makes sense that they feel that way because to think about it, whiteboards like these have been around since 7 decades ago, and that's about 70 years already, and so it's time to understand that whiteboards have become an old and inefficient way of transferring and visualizing information at this modern day and age when all sorts of amazing and capable technologies are at our disposal. To further prove my point, I have conducted a survey with 58 teachers on their dissatisfactions with whiteboards. Among the 58 teachers, 45 of them uses whiteboards because they needed to make handwritten notes. And among these teachers, 25 of them wanted to show MP4 videos to their students but were unable to with whiteboards. Another 19 of those teachers have soft copy textbooks that they were unable to use in class because they needed to write on whiteboards and they weren't able to use something like a projector. So I'll call that no multimedia support on whiteboards. 1 out of 58 teachers even complained that he couldn't show physics simulations to demonstrate a concept to his students. So that's no interactivity. On the other hand, 13 of the 58 teachers surveyed uses projectors and PowerPoint presentations to teach their classes, and they use it to be able to utilize their digital assets like soft copy textbooks, videos, and PowerPoint presentations. However, all 13 of these teachers share the same dissatisfaction, which is they cannot write and draw with marker pens. Instead, they are forced to use computer mice and keyboards to make notes. Teachers not having access to a dynamic teaching medium is really impacting the efficiency of our educational system, and as a student myself, that problem is, I think, the source of my inspiration to create a digital interactive teaching device that will drastically increase the teacher's ability to visualize and convey information. So today, 5 months have passed since the first time I've started working on my innovation, and today I'm finally proud to present to you the airboard system, and here it is. Alright, so this right here is a normal projector setup that you can find in almost every school now. And the thing about this setup is that all it does is it projects the contents on my computer screen onto a larger surface for a larger audience to see, right? There's nothing really special about this setup. You can't interact with the contents on the projection screen. It's just an enlarged projection of your computer screen. However, once you upgrade this normal projector setup with the airboard system, it enables you to use a special pen or stylus to interact with the projection screen, and in fact, you could even do some handwriting and drawing on it. That's really cool, isn't it? So I think it's finally time for me to show you how the entire airboard system actually works. Now, the airboard system is called a system because it is made from three main parts. Number one, the air pen stylus, and number two, the air sensor, and number three, the airsoft, which is a custom program that I've coded entirely from scratch with Python 3 and Microsoft's OpenCV library. If you want to pause the video right now to take a look at the poster on screen, do go ahead. But I'm not going to dwell too long on that poster right now because I can physically show you how the entire airboard system actually works. So this thing right here is the air pen stylus. Now it's basically an old whiteboard marker, and I've took out all of the insides and I fit in a AAA battery inside of this thing, and this is a button that I've soldered on right there, and the tip. Now the tip is the most special part about the entire pen because the tip is an infrared LED. Now the difference between an infrared LED and these normal LEDs is that an infrared LED shoots out infrared light, and infrared light is invisible to the eye. So it's basically invisible and it's actually working, and it's just that you can't see it. So what happens when I start writing on the projection screen is that when I press the button, the infrared LED will shoot out infrared light, which is invisible again, and this light will hit the projection screen and it will bounce back. It will reflect back into the airboard sensor. And right now my airboard sensor is beside my projector right here there, and it's out of frame because it's behind the camera. So that's exactly why I took a picture right here, and you can see the projector right there, and that black box on top of that projector, that small box, is the airboard sensor, which will pick up all of this invisible infrared light and then convert it into a coordinate set. Now this coordinate set will be sent across to my computer, which is connected to the projector right there via Bluetooth 3.0. Now Bluetooth makes this whole thing wireless, so essentially the airboard sensor is wireless. And on top of inside my computer, I'm running my airboard Python program, which will take the coordinate set and run some algorithms on the coordinate set, including perspective transformations, gain tolerance, and smoothing. And once the processing is done, the final coordinate set will be converted into actual mouse locations. So it's like simulating a mouse, and it will be converted into mouse cursor positions. So these cursor positions will be projected back to the projection screen because it's on the desktop. And if calibrated properly, if the airboard system is calibrated properly, the mouse cursor's position should be directly underneath the air pen stylus. So I may have a small confession to make. If you see this small black airboard sensor module right there, well, part of it actually came from something like this. Now this little thing is actually an IPTV, which is like a wireless CCTV. And one of my IPTVs broke, and so I ripped the entire thing apart to salvage the camera module right there. And because these IPTVs are night vision capable, that means that the camera module inside of it is infrared sensitive. So you look at this infrared module right there, that's basically the camera module that came from one of these IPTVs. I've basically took it out and connected it to a Raspberry Pi, which will then broadcast the coordinates, the image sets to the computer. And so what this means is that part of the airboard sensor is actually a camera. And when you have a camera in the airboard system, you basically get footage. So that's exactly what I'm going to show you right now. I'm going to show you the raw footage coming from the airboard sensor's camera. Now, to be able to show you the footage that's coming out from my airboard sensor's camera right there, I'm going to have to use my custom Python airsoft program right here. And this is it. It's just a black text-based terminal console. And the reason for this is because I haven't had the time to create a graphical user interface yet. So this is what I've been dealing with for the past 5 months as my first prototype. So this has got to be one of the future developments for this project, and that is to create a nice, beautiful graphical user interface. So to start the program, I'm going to type this command in right now, which is Python airboard.py, and let's hit enter. Right now, this program is going to start up, and whoa, this is what we get, a blank canvas. Now watch what happens when I activate the air pen stylus right here. When I press on the button right here, whoa, you see there's one blob being tracked right there, one bright blob being tracked right there, and these are the coordinates of that blob. You can see me move it around, and this number right here is basically the gain or the sensitivity or the brightness of the blob. So it even works while being reflected off of the projection screen. Now if you can see here, the reason I'm getting such a clean tracking with the airboard system is because I've isolated all of the light, the wavelengths of light that can get past and reach the airboard sensor. And I've only allowed light with the wavelength of 940 nanometers to reach the airbot sensor. So all of the light that you see here is 940 nanometers, which is IR, which is the light coming out from this LED right here. And I've done that by using an IR filter to block out all the light. So imagine me removing that IR filter right now, which is this piece of black thing right here, and this is what you get. Whoa, you get like an actual footage of me waving my hand. And the reason for this is because that camera on the airbot sensor is basically just a normal camera, and it's just IR sensitive, so you get this kind of purple tint going on right there. And now if you look at my footage right here, you can see that there's a bright spot there at my hand. It's basically the AirPen stylus. You can't see that with the normal camera that you're seeing right now, but if you look at the footage at my airbot sensor, you can see that it's actually really bright. Not bright, really bright. Not bright in the normal camera, really bright in the footage behind me. Now, because I've removed the IR filter, all sorts of light, even visible light, is passing through and reaching the IR sensor of my airbot sensor right there, and this is going to create a lot of noise and chaotic interference with my signals. So even my light up there is going to interfere, and it's going to result in a very messy tracking. So that's all of the airbot system's engineering work in a nutshell. Now, let's move on and look at the marketable values of the airbot system instead. First of all, the airbot system will be able to digitalize education. And I'm saying this right now because with airbot, teachers can do all sorts of computer stuff in the classrooms, including directly annotating on PowerPoint presentations, drawing on PDF files, creating, storing, and sharing notes digitally. Hey, some teachers could even utilize the processing power of a computer to visualize and teach complex mathematical concepts by using interactive 3D models and physical simulations that you can physically interact with using the AirPen stylus. Or mathematics teachers could utilize graphing tools and 3D models from the internet. Honestly, with internet access, the possibilities are limitless. Alright, next up, the airbot system is Industry 4.0 compliant in that it puts real-time computing into the classroom. Also, because the airbot system is digital, teachers can easily make notes digitally and then save these notes digitally, and then finally share them out with their students digitally through online portals such as Google Classroom or OneDrive. And you know what this means? This means that the airbot system is capable of directly revitalizing our government's initiatives to digitalize learning in the classrooms with online platforms such as VLE Frog, One Best Net, and DL Digital Learning. And this is because the gap between the physical world of pens and papers and books and the digital world of computers and the internet can be reduced if the airbot system is implemented in all schools throughout the country. These are the parts that I had to purchase for my prototype. For your information, I've managed to create the final airbot system prototype with just less than 100 ringgit Malaysia, which is just mind-blowing because it's literally 1% of the cost of the entire airbot system. So arguably, you can fill 2 whole schools with airbots from the money to buy just 1 unit of smartboard. That's crazy, isn't it? So upon the completion of my final prototype system, I've installed a unit of airboard in a testing environment for teachers and students to use. And here is the data right here. Now, these are the many questions that I had asked the survey participants to answer, but the summary is just that 98% of 58 teachers and 60 students preferred airboard over whiteboards. And one more thing, the airbot system has also been used by VIPs like our school's chairman of the Parent Teachers Association and also our state's director of education from the Selangor Department of Education to sign and launch events like the launching of my school's Google Classroom platform and digital learning portal. And alright, so I think it's time for the conclusion now. Humans used to carve on stones to convey and store information. Then we evolved to using chalkboards before evolving again to using whiteboards and projectors. 7 decades have passed and it's time for us to evolve once again to use airboards as the mainstream presentation medium. And if airboards succeed, it will be able to aid in technological revolutions of the 20th century because it's Industry 4.0 compliant and it fulfills Goal 4 from the United Nations Sustainable Development Goals, which is to increase quality of education. Education is the key to a country's development, and it is the goal of the airbot project to propel our country to a new age of wealth and prosperity by revolutionizing the way we humans teach and learn. Thank you.